This is Geometry, Unit 7, Day 2 worksheet. We're first going to work on the wheel of Pythagoras. So what we're supposed to do here is find the hypotenuse of each triangle. What do you notice about the solutions? There's going to be a pattern as we work our way around. So here we're starting with a right triangle, and it has a right angle, two sides of the same length. So we can call this like triangle A, triangle B, C, D, E, F, G, H, I, J, and K. So with this triangle, we have 1 squared plus 1 squared, and that's going to equal this value here. Let's call that side A. So 1 plus 1 equals A squared, so that's 2 equals A squared. So the square root of 2 is what this side's going to be. So now we come over here to this other triangle. It has a length of square root of 2, a length of 1, and we're supposed to find the hypotenuse. So let's call this side B. So we have one side called the square root of 2, one side a length of 1, and we're going to figure out what the B side is. So when you square a square root, you get what's inside. And we got the value of the cubed root of 3. So we turn our triangle, and now we're going to work with this cubed root of 3 and with 1. We're going to figure out what this hypotenuse is. So the two lengths that we have is a cubed root of 3 and 1. Cube root of 3 squared plus 1 squared equals the C squared. Then when we take the square root of both sides, we'll get a length of 2. So this C length is 2. Now we move on to the next triangle. We have a length of 2 and a length of 1, and that's going to be a hypotenuse of D. So we're going to look at 2 squared plus 1 squared equals the D squared. So we get the square root of 5. And then we move on to the next one. Call this one E. So we have the square root of 5 squared plus 1 squared, and that equals our E squared. When you square a square root, you get what's inside. And I think we're definitely starting to see the pattern. But I'd like you to show your work. Just a good practice on how you set these up and how you do the math. So now we have the square root of 6 squared we have a length of F. Leg squared plus leg squared equals hypotenuse squared. Take the square root of both sides. Square root is 7. We have square root of 7 squared plus 1 squared. And that's going to give us the length of G. Well, when we take the square root of G and take the square root of 8, we can simplify that 8. So this actually becomes 2 square root of 2. A length of H. So we have 2 square root 2 squared plus 1 squared equals H squared. When you square something that looks like that, you would square the 2 on the outside, then you'd square the 2 on the inside of the square root. The square root of 4 is 2. So we get a value of 3 for H. So now we have this triangle that has a length of 3, a length of 1, and we're trying to figure out what the length of I is going to be. So we have 3 squared plus 1 squared equals I squared. And because 10 is made up of 2 and 5, it doesn't have any perfect squares that we can help simplify. So square root of 10 it is. Then we have J. So over here, I'll do some more with J. So we're going to take the square root of 10 squared, because that's one of the legs, plus 1 squared, because that's the other leg, equals J squared. When you square a square root, you get what's inside. So J is going to be the square root of 11. And then our last one that we'll do is here at K. So square root of 11 squared plus 1 squared equals K squared. So we take the square root of both sides. Now 12 can be broken down into a 4 and a 3. Some people might think of 2 and 6, which is totally fine, but neither of those are perfect squares. When you use the 4, then you can clearly see that the square root of 4 is 2. We didn't use the 3, so the 3 stayed inside the square root. So that's why it's 2 root 3 equals K. That completes our wheel of Pythagoras. We calculated the hypotenuse for each triangle all the way around. On the next side, we're going to solve the following right triangles for the missing side. We'll show our steps. Now remember, we use Pythagorean Theorem when we solve these. This is a right triangle. You can only use Pythagorean Theorem with a right triangle. Leg squared plus leg squared will always equal the hypotenuse squared. So in this case, the leg squared is 40 squared, and the other leg is 42, so squared. That has to equal the a squared. So when we say 40 squared, we're going to come up with 1600. And we say 42 squared, we'll come up with 1764. We can add those two together. And get 3,364. And when we take the square root of that answer, it comes out to be 58. So that is an example of what's called a Pythagorean triple, because all the sides of the right triangle are an integer, actually a whole number. Whole numbers are positive counting numbers. So A is 58. Here, your legs, the legs are always the perpendicular sides, so the hypotenuse is always across from the 90. So when you're setting up your Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. It's important to have the B be adding to the other leg, because in this case the unknown is a leg length. So leg squared plus leg squared equals hypotenuse squared. So when we square 11.2, we get 125.44. And when we square 19.3, 372.49. So now we're going to subtract the 125.44 across. And we take the square root of that. Taking the square root gets rid of the square with the b. It puts the square root over that value, which is going to be approximately 15.71. So we'll round that to 15.7. Round to the nearest tenth if necessary. Here we have leg squared plus leg squared equals hypotenuse squared. The legs, remember, are always the perpendicular sides. The hypotenuse is always across from the 90. Subtract the 49. And then when we take the square root, and it does talk about simplifying, or rounding to the nearest tenth. Let's simplify this first, just for that good practice. So what is 120 made of? Well, I know that 40, let's say 4 times 30. 4 times 30 is 120. I know the square root of 4. Now 30 is made up of 6 and 5. Neither 6 or 5. 6 is 2 and 3. So if you think about it, square root 30 is 2 times 3 times 5. We don't have any pairs of the same number. So that's our final answer. In a decimal version, we have 2 square root 30 as 10.95, which if we round that to the nearest tenth, we would get 11. To find the area of a triangle, we know that area of a triangle is half the base times the height. Well, the base and the height have to be perpendicular to each other, so those are always going to be the legs of a right triangle. So in this case, we need to come up with what the other leg is for us to figure out what the height is going to be. The 13 isn't extremely helpful for us in the area. It does help us, though, figure out what the other height is. So we need to remember leg squared plus leg squared equals hypotenuse squared. Subtract the 25. And when you take the square root of both sides, we get the value of 12. So the area is going to be half the base times the height, which is half of 60. 30 units squared. Looking at number 5, this is your base. This dotted line is perpendicular to the base, so that would be considered the height. Now, we don't know what the height is, but if you notice, height is always perpendicular to the base. So we can use the 17. The height, we know that it has two sides that are equal length. So we've learned before, if a point is equal distance to the endpoints, then it's on the perpendicular bisector. So we know that this is 8 on both sides. This would be considered your h. So we have 8 squared plus h squared equals 17 squared. Our 17 squared is 289. We'll subtract the 64 to get 225. Take the square root of that, which equals 15. So now the area equals half the base. The total base, you could say, is 16. The height is 15. You could either multiply the 16 and the 15 together, which would be pretty common, and then take half of it, or you can take half of either the 16 or the 15. Since taking half of 15 isn't quite as easy, I'm going to take half of the 16 to get 8 times 15, which is 120 units squared. Area is always square units. Here we have a similar problem. We have this point that's equidistant to the endpoints of a segment. So we know that it lies on the perpendicular bisector. So that's going to make both of these segments 6. So for us to figure out what this length is, we can call it base, we can call it height, whatever you like. If we turn it sideways, you might really see how it could be considered the height. If this is your base, that would be up to be your height. So we say 6 squared plus h squared equals 10 squared. When we say 10 squared, we could write 100. Take the square root of 64, and we'll get 8. Now we can use that 8 in our area formula. The base, which if you wanted to call that 12, and the height, if you want to call that 8. You can take half of either one of those numbers, just don't take half of both of those numbers. In this case, it's m. It's not just units, it's meters squared. And now since I notice these were centimeters, so I didn't have to just put units, I could put centimeters squared. For 7, 8, and 9, the given lengths of two sides of a right triangle. All three sides of the triangles are integers, so they're a Pythagorean triple. Find the length of the third side. We got to decide if it's a leg or a hypotenuse. So let's first look to see if the missing side is a leg. If the missing side is a leg, then the largest number is considered the hypotenuse. So let's look to see when this is a leg. So we'll say 24 plus x squared, because it's leg squared plus leg squared equals hypotenuse squared. So 24 squared. And when we come up with those calculations, we get 576. And 51 squared, we'll get 2,601. We'll subtract our 576. And I don't believe that that's going to be a perfect square, but it is. Take the square root of 2025. Well, of course it has to be, because these are Pythagorean triples. So the leg is 45. On this side, let's look for the leg. So that's going to assume that the 96 is the hypotenuse. 28 squared plus x squared equals 96 squared. 28 squared (96 squared) when we subtract the 784, and we take the square root of that number, we get this 91.8. So we know, because it came out to be a decimal, that this missing portion was not a leg. The missing portion must be a hypotenuse. So let's try that. Let's look for the hypotenuse. So that would make us say 28 squared plus 96 squared equals the hypotenuse squared. We'll take the 96 squared and add that to the 28 squared, and we get a perfect 10,000. That seems like a reasonable perfect square, which comes out to be 100. So the missing side is a hypotenuse, which is 100. On this side, now I'm going to look here and I'm going to notice that the 75 and the 85 seem kind of close to each other. So maybe the missing side is a hypotenuse. I'm not sure. Let's find out. So let's look for a hypotenuse. So your unknown leg plus your other leg has to, well, I'm sorry, your unknown leg is going to be the unknown value is going to be the hypotenuse. And when we add those two together, and take the square root, we get a crazy decimal. So we know that the missing side is not a hypotenuse, it must be a leg. So let's look for the leg. So x squared plus 75 squared equals 85 squared. I put in my numbers backwards. 75 squared is 5,625. 7,225. So that looks like 1,600 to me. Yeah. So x is going to be 40. So the leg equals 40. So now we're supposed to leave our answers in radical form. We're looking for E. If these two are the same lengths, then we'll try to solve for what E is. So 9 plus 36 equals E squared. 45 equals E squared. So the square root of 45 equals c. 3 square root 5 is the c value. Here, these are all the same lengths. They all have the same tick marks. So we get 11 for each one of those. 11 squared plus 11 squared equals f squared. 121 plus 121 equals f squared. So when we take the square root of 242, that's going to be 2 times 121, which is 11 square root 2 is the value of f. And then lastly, on this side, this is 3. We're looking for this side. So to find out that side, let's call it h. I believe this is going to be called the Pythagorean Triple. So h is going to be a 4. And then we can use the 4 to help us figure out what the g length is. Take the square root of 65. 65 can be broken down into 5 times 13, but neither of those are a perfect square, so the square root of 65 works. G is the square root of 65.